Welcome to this explainer. The AI revolution we're all watching unfold right now, it didn't actually start with some flashy product launch or a massive neural network. Actually, scratch that. It started with a fundamental shift in human imagination. Today, we're going to look at how philosophy, advanced math, wartime computing, and just pure, unfiltered human ambition all converge to create an entirely new scientific field. And this isn't just dusty history. It absolutely explains why the massive tech breakthroughs you use every single day still carry the exact same assumptions, hopes, and even the blind spots of those very first researchers. Okay, let's dive into this. It all really starts with a seemingly impossible four-word question. Can machines think? At the time, that sounded like pure science fiction, right? But it was this exact question that literally forced scientists to stop treating computers as just glorified calculators and start imagining them as something entirely different. Long before the phrase artificial intelligence was even a thing, engineers were already cobbling together the basic ingredients. They were building machines to manipulate symbols and memory by mechanically following super rigid instructions. And these early computers made that process feel incredibly concrete. But the real tension? That was figuring out the leap from pure calculation to actual cognition. The much harder question was whether crunching numbers could eventually evolve into reasoning, learning, communicating, and solving complex problems. So, the journey to that massive mental shift basically took a whole decade. In the 1940s, we proved that symbols and memory could be manipulated. But honestly, the definitions of what it actually meant to think were still incredibly vague. That is until 1950, when Alan Turing stepped in and shifted the paradigm entirely with a behavior-based test. And that momentum, it carried us straight into a pivotal summer in 1956 at the Dartmouth conference, which officially birthed the field as we know it. Act 1. Turing reframes the problem. Right, so in 1950, Alan Turing did something completely radical. He outright refused to get trapped in those endless philosophical debates about what constitutes a soul or a mind. Instead, he offered a practical doorway. He said, let's measure the performance first and argue about the metaphysics later. This brilliantly illustrates what we now call the Turing Test. He basically argued that if a machine's behavior became indistinguishable from human conversation, well, we could measure and improve it. He took a philosophical mystery and turned it into a concrete, testable experiment. Turing's deeper mental model here was absolutely fascinating. To him, a machine wasn't just hardware anymore. By receiving symbols, manipulating them with formal rules, and using search and feedback, it became a general-purpose symbol system. It was suddenly capable of carrying out instructions that looked surprisingly close to human reasoning. It's like he gave us a blueprint for thought. What this did was build a vital, narrow bridge between two totally different worlds. On one side, you have strict, formal mathematical logic. And on the other, the incredibly messy human psychology of memory, perception, and choice. Early AI researchers were essentially asking this massive question. Can the beautiful mess of human thought just be reconstructed as a cold, mechanical process? Act 2. The Dartmouth Fulcrum. Okay, moving to the summer of 1956. This is when John McCarthy officially coined the term artificial intelligence for a research project at Dartmouth College. Now, what's really wild about this moment is their staggering hubris. They genuinely thought a 2-month, 10-man study could just solve major aspects of human intelligence. No big deal, right? Well, they obviously didn't magically solve it that summer, but they did do something just as vital. They gave the field its name, a shared, unified vocabulary, and a public promise that science could now literally build intelligence, not just debate it. The pioneers who gathered there came from completely different disciplines, but they shared one massive bet, that intelligence was an engineering project. You had McCarthy pushing programming languages, Minsky exploring perception and learning. Shannon brought information theory to the table, while Newell and Simon tackled symbolic problem solving. If reasoning had an underlying structure, they firmly believed software could expose it, test it, and scale it up. Act 3. Early wins and hard limits. In the immediate aftermath of Dartmouth, these pioneers saw some explosive psychological wins. Systems like the Logic Theorist were actually out there proving mathematical theorems. You had the general problem solver actively solving tasks by comparing states. And then there was ELIZA, which created this incredibly powerful illusion of human empathy using just simple text patterns. These modest little mechanisms completely shifted human expectations, making true intelligence look deceptively easy to build and highly decomposable. But those early demos had a glaring difficulty. You see, symbolic systems worked brilliantly in what we call clean worlds, environments with explicit rules, like chessboards or math equations. But man, they hit a massive brick wall in noisy worlds. It's a classic paradox. An AI could solve advanced calculus, but it literally couldn't figure out how to recognize a cup of coffee or navigate a messy room. The real world doesn't come with explicit rulebooks. It requires common sense, visual perception, and a massive tolerance for ambiguity. So the crucial point here is that researchers quickly discovered intelligence wasn't just one single problem to be solved. It was this massive interacting stack of representation, search, memory, learning, embodiment, language, and judgment, all firing at once. Early symbolic systems just couldn't handle that level of messy, simultaneous complexity. It was just too much.
Act 4. The modern AI echo.
Now, it's really important to note that those early systems didn't actually fail. They became the absolute foundation for modern AI. The search algorithms, knowledge representations, and natural language interfaces that we use today, they all trace directly back to Dartmouth. It only feels brand new today because the scale changed. The hardware changed completely, datasets absolutely exploded in size, and the models got infinitely larger. But that original architecture of curiosity, that core culture of bold experiments forged by McCarthy, Turing, and Minsky, that remains exactly the same. Which brings us right back to the beginning. Turing gave the field a testable question. Dartmouth gave it a name and a sky-high ambition. And every single modern breakthrough we see today, from massive language models to autonomous agents, it all still echoes that original, seemingly impossible question. Can machines think? And if they can, what should we build next? Thanks for exploring with me on this explainer.